Hey, it's Skylar. Today, some friends of mine are taking a ride in a hot air balloon. I've been helping out at the launch site. Boy, there sure is a lot that goes into getting a balloon aloft. First, the balloon crew needs to find an open spot, free of trees and buildings, for the launch point. They need plenty of room to lay out and inflate the envelope, or bag, of the balloon. Now that the balloon's inflated, they're ready to take off. It's a perfect day for a balloon ride, and it's a perfect opportunity to discuss the law of signs. So get ready to go up, up, and away, and get another problem solved. It was a beautiful launch. The chase crew has taken off after the hot air balloon, and I'm staying here at the launch site. I'll catch up with them later. My friend Kyle is waiting at the landing point to help safely moor the balloon. I just spoke to my friend Doug, who's up in the balloon taking photos. Doug just took a picture of Kyle at the landing point off in the distance. He's wondering how far the camera is away from Kyle. That's where the law of signs comes in. I'll show you. See how the launch point, the balloon, and Kyle determine a triangle. We can find this distance by using the law of signs. First, start with what we know. Kyle is 3 miles from the launch site. Next, Kyle and I can find the angle of elevation using clinometer apps on our phones. The angle of elevation from the launch site is 16 degrees. Kyle, what's your angle?
The angle is 8 degrees.
The angle of elevation from his end is 8 degrees. Okay, by subtracting the measures of the two angles from 180 degrees, we can find the last angle is 156 degrees. So, we know all three angles but only one side length. Is this enough information to figure out the distance between the balloon and Kyle? To answer that, we need to ask, what's the relationship between the lengths of the sides of our triangle and the measures of its angles? Frequently, when we are trying to find a missing side length or angle measure of a triangle, a good approach is to use right triangles. Right triangles tend to be easier to deal with because we know a lot about them. From studying right triangle trigonometry, you may recall sine, cosine, and tangent. The sine of an angle is the ratio of the opposite side length divided by the hypotenuse. Cosine is the adjacent side length divided by the hypotenuse, and tangent is opposite over adjacent. Notice all of these functions are ratios of side lengths. Given any triangle, we can divide it into two right triangles. Then, using the sine ratio from earlier, we have the sine of A is equal to h divided by c, and the sine of c is h divided by a. Notice the height is a variable in both of these equations. If we solve for the height, we get c times the sine of a equals h, and a times the sine of c equals h. Since c times the sine of a equals the height, and a times the sine of c equals the height, we can set them equal to each other, and we have c times the sine of a is equal to a times the sine of c. Rearranging the equation, we get the length of side c divided by the sine of angle c is equal to the length of side a divided by the sine of a. This is called the law of signs. Here's a cool thing. After all that algebra, h isn't even part of the equation anymore. The law of signs means that for any triangle, if you divide any side length by the sine of its opposite angle, and divide another side length by the sine of its opposite angle, you get the same value. Notice that while the side lengths and the angles change, the ratios remain constant. So, there's a relationship between the sines of the angle measures and the lengths of the opposite sides. What? Yeah, hold on. Doug's anxious for us to get back to our original problem. So let's see how this relationship can help us. We can use the law of signs to find the distance between the balloon and Kyle. Remember, the landing point is 3 miles away from the starting point. As we found earlier, its opposite angle measures 156 degrees. Now, setting up a proportion using the law of signs, we see that 3 divided by the sine of 156 is equal to the distance to the landing d divided by the sine of 16. We use 16 degrees because it's the angle opposite to the distance we're trying to find. Multiplying both sides by the sine of 16, we get the sine of 16 times 3 divided by the sine of 156. Calculating this equation tells us that the picture was taken from 2 miles away. 2 miles. Yeah, 2. We used the law of sines. I think he's scared of heights. Let's review. The law of sines is used to find angle measures and side lengths in triangles. So, when can we use it? You can use it when you know an angle measure and its opposite side length plus one additional angle measure or one additional side length. The law of sines is a proportional relationship involving lengths and the sine of the opposite angle. A over the sine of A is equal to B over the sine of B and C over the sine of C. See? Your understanding of the law of sines is soaring to new heights. Now, if we can just get Doug back on the ground safely. Problem solved!